In continuation, Windows and Unix file system have here Macintosh file system. The original Macintosh filing system of or was limited to keeping track of 1 to 8 documents, applications, or folders. This was a reasonable when the only storage device was a 400 KB floppy disk drive. As larger disks became available, however, the need for folders and subfolders became obvious, and Apple responded with the hierarchical filing system, 1986. Like FAT16, hierarchical filing system divides a volume into at most 2 to the 16th power of units, or 65,536 units. Volume is the Mach term for a disk or disk partition. On personal computer systems, these units are called clusters or allocation units. On the Mac, they are called allocation blocks, but the principle is the same. While Unix or Linux and Windows operating systems report file sizes in terms of their actual size, the Macintosh operating system sometimes reports file sizes in terms of logical size based on the number of allocation blocks occupied by the file. The best way to view the actual size of a file is to use Max get info option, which shows many other types of information about a file. In 1998, Apple released macOS 8.1, which introduced a new disk format, hierarchical filing system extended format. And this format was variously referred to as macOS HFS plus macOS extended or macOS extended HFS plus, which is used today in Mac OS X. The newer hierarchical filing system format increases the number of allocation blocks per volume to 2 to the 30th power. This format creates smaller allocation blocks or clusters and more efficient disk utilization. Systems that use Mac OS 8.1 or later can format disks in either Mac OS Standard or Mac OS Extended hierarchical filing system format. However, the Macintosh with pre 8.1 versions of the OS can't read disks in extended format. In Mac OS X version 3.0, Mac OS Extended hierarchical filing system includes several few features. We have an optional case-sensitive format to make the file system more compatible with other Unix or Linux system. The journaling, which is turned on by default so that data can be recovered from a journal file if a disk or system problem occurs while data is being updated or modified. And lastly is the ability to store up to 16 terabyte of data, which is particularly important for the Mac OS X server version. The first two sectors of a Mac formatted disk are the boot sectors or boot blocks in Macintosh terminology. The boot blocks identify the filing system, the names of important system files, and other important information. The boot blocks are followed by the volume information block, which points to other important areas of information as the location of the system files and catalog and extents bits. Catalog bit tree is the list of all files on the volume. It keeps track of a file's name, logical location in the folder, its physical location on the disk surface, and the locations and sizes of the file's data fork and resource forks. The extents B tree keeps track of the location of file fragments or extents. Macintosh can read and write to disks from other operating systems. For instance, Mac can read ISO, CD, or DVD-ROMs using a dedicated driver. Macs can also read all manner of Mac or MS-DOS and Windows formatted disks, thanks to pre-Mac OS X tools such as the PC Exchange Control Panel, and thanks to various Mac OS X tools such as those offered through System Preferences and as disk utilities. Mac OS has always supported what might be called medium length file names, up to 31 characters. The use of a period as the first character in a file name is discouraged because older versions of the operating system used a period as the first character of invisible driver files. Any character may be used in a file name except the colon, which is only by internally used by the macOS as a folder separator that is equivalent to slashes in other OS. And for this reason, Macintosh paths are written as colon separated entries, like hard drive, colon, system folder, colon, preferences, colon, finder, refs. Unix and Linux and Windows operating systems use file names such as .txt and .gif to identify the file types. The Mac uses type codes and creator codes, and as an example, files created with Apple's simple text editor have a type code of APPL and a creator code of txt. When a user double clicks such as a file, the Mac knows it must open the file with an application, like type with the Apple format and a creator code of txt format. And you can view a file's creator code, such as JPEG file for a graphic, by using the file's get info option. The type and creator codes facilitate the Mac's use of icons. Documents do not store their own icons. Instead, the Mac gets the icon creating function. Instead of accessing the application each time, the icon must be displayed. The Mac stores the icons and file associations in invisible files called the desktop databases. Now, because file Macs have type and creator codes and two forks, can create problems when storing files on non-Macintosh servers. We have the Mac binary um, format, which joins the two forks into one, safely stores the type and creator codes and finder flags. Now, Windows um, equivalent to Apple for creating a shortcut is using the alias. So this is the system level alias manager, which keeps track of the origin. And this alias is tagged onto the file name. It's great. File name is italicized. And there are two disk utilities that comes with Mac OS X. We have the disk utility, the first aid disk, or the disk first aid. The disk utility manages the disk drives, and the disk first aid repairs the disk problem, as the name implies. And also, Mac OS X comes with a utility Sherlock that searches disks for file names and text within files. The Sherlock or Spotlight, okay, which was replaced Sherlock in Mac OS X version of Tiger, the 10.4 version. Although Sherlock continued to ship with macOS until it was officially retired with the release of macOS X 10.5 Leopard. And macOS X users have always faced the same problems as Windows users when it comes to organizing and finding files. So nothing is more frustrating than knowing you have created and saved a document, spreadsheet, song, or photo and being able to find it. Spotlight does the following for the users. Okay, we have the indexes files, so you can find them faster. The It enables you to search for something just by typing a few letters of the names, as in Windows. And it quickly searches the computer's nooks and crannies for what you want, even if you're not sure how to spell it exactly. And it works in conjunction with the smart folders capabilities and organize files you found according to characteristics you use. And one reason for Spotlight's speed is that it indexes not only by file names, but by metadata associated with documents, such as the author, creation, date, lots of other information. It also indexes based on individual words inside regular text files, word processing files, and even PDF files used by Adobe. But Spotlight doesn't work on files with Unix system and kernel. For these files, you have to use Unix commands such as find or locate. You can start Spotlight by clicking the blue magnifying glass icon to the right of the clock at the top of the desktop in Mac OS X. Now, the Mac is extremely versatile at booting from different devices, like other operating systems. When the Mac is shut down, normally using the Apple Minus shutdown option, a flag is set on the hard drive. The event of a crash or forced reboot, this flag is not set. The flag is not set, the Mac will see during the next startup that the computer was not shut down properly and run a disk in check. Now, since it has the features of extreme versatility, like other operating systems, the Mac will boot from CD or DVD ROM inserted during the boot sequence. If the disk does not contain a valid system folder, the Mac will eject the disk and continue searching for a bootable device, such as the side device. Since the early 1990s, Macs have been able to boot from DVD or CD-ROM drive. Simply press the C key while booting up. Pressing the Shift Option Delete Apple or the soda keys during the boot sequence will bypass the internal hard drive and boot from the next drive in the a side chain. And that's the end of this module file system.